The most familiar planets orbit around the Sun. But there are other planets as well, planets that orbit around other stars. These planets are called exoplanets. What do we know about these planets? Are they just like the planets in our solar system? Also, is there an exoplanet that is just like our Earth? Watch on to find the answers to these and many other intriguing questions about exoplanets. The majority of stars have solar systems. Some exoplanets are very similar to the fictional world found in Hollywood movies. Out of those, some have turned out to be exotic beyond our imagination. There are over 100 billion galaxies in our universe. Each of the galaxies has hundreds of billions of stars. If most stars have one or more planets around them, there may be billions or trillions of planets in the universe. As of October 2021, scientists have found over 4,000 exoplanets, and the hunt for exoplanets is quite far from complete. Astronomers harness powerful telescopes to search for exoplanets in the night sky, and they are never disappointed. Surprisingly, NASA's Kepler Space Telescope alone detected nearly 2,600 exoplanets after almost 10 years. In terms of size, these exoplanets range from sub-Earth size to gas giants that even make Jupiter look smaller. Though there is a significant variation in densities, some are dense as styrofoam while others have iron. The exoplanets close to their parent or host stars have scorching temperatures of thousands of degrees. Moreover, they are distant from their stars at least 10 times farther than what Jupiter is from the Sun. One of the key areas of research in astrophysics is how planets and exoplanets form. Let's explain this starting from the dust around a star. Well, the dust around the star has the critical ingredients for forming a celestial object around it. It contains carbon, iron, and many other elements that are crucial in creating planets. A star ejects scorching winds dominated by positively charged particles called protons and neutral helium atoms during what is known as a T-Tauri phase. Even though most of the material from the star disk falls on the star in this phase, small groups of lucky dust particles crash into one another and clump into oversized objects. These dust clumps then become pebbles, which form into larger rocks, resulting in grinding and expanding together. What makes this solid material stick together? A gaseous atmosphere. Some of these building blocks may break off, but some still hold on. Such building blocks are called planetesimals, which means the formation of any solid object during the accumulation of orbiting bodies. Typically, planetesimals are approximately 1 kilometer in the solar nebula. Icy fragments start combining with the dust in the regions where the disk is colder. Such areas are usually far off from the star. The dirty snowballs form, then transform into giant planetary cores. These colder regions allow gas molecules to slow down enough to be drawn onto a planet. It is precisely how the gaseous giant planets like Jupiter, Saturn, Uranus, and Neptune are formed. Rocky planets begin to form in the warmer parts of the disk. Such regions are closer to the star. Not a lot of gas is left for the terrestrial planets to accrete once the icy giants form. Rocky planets like Mercury, Venus, Earth, and Mars may take millions of years to develop properly. Why do planets prefer to form in disks? It is a mysterious phenomenon that astrophysicists are still trying to figure out. Rocky exoplanets are abundantly present in our local Cosby neighborhood. It is as if nature has a liking for forming exoplanets. Scientists have already found thousands of exoplanets. It would be a lot to expect if they don't categorize them. The 4 key types of exoplanets include gas giants, Neptunian planets, super-Earths, and terrestrial planets. Gas giants are planets almost the size of Saturn or Jupiter, the largest planet in our solar system. Some gas giant exoplanets are even more significant than them. Gas giants are a diverse group of exoplanets. Hot Jupiters are the most fantastic group of planets. These orbits are so close to their stars that their temperatures soar up to thousands of degrees. Many hypotheses explain how hot Jupiters get so close to their parent stars. Come to think of it, this one makes more sense. Some of the most famous gas giant exoplanets include Kepler 7b, Kelp 9b, and HIPS 67522b. Neptunian planets are called so because they are similar to Neptune, one of the planets in our solar system. Their interior composition is a heterogeneous blend of elements, but hydrogen and helium-dominated outer atmospheres and rocky cores are a common theme in such planets. Neptunian exoplanets often have thick clouds that block any light from coming through, hiding the signature of the molecules in the atmosphere. Scientists have also discovered many Neptunes. These are the exoplanets that are more diminutive than Neptune but bigger than Earth. Such many planets don't exist in our solar system. Exoplanets like HAT P26b, GJ436b, and at P11b are all Neptunian exoplanets. Super-Earths can be 10 times as massive as the Earth. These are typically terrestrial planets that may or may not have atmospheres. Back in 2016, observations from NASA's Spitzer Space Telescope led to the successful creation of the first-ever temperature map of the Super-Earth 55 Cancri. This map revealed extreme temperature swings from one side of the planet to the other, suggesting that the reason for this is lava flows. Some of the familiar super-Earths now include Gliese 581c, Kepler 62f, and Kepler 10b. Terrestrial planets can be Earth-sized or smaller. These exoplanets are composed of rock, silicate, water, and sometimes carbon. Further investigation can determine whether some of these exoplanets possess atmospheres, oceans, or any other signs of habitability. NASA discovered the most Earth-sized planets in the habitable zone of a single star called TRAPPIST-1 in 2017. In February 2018, a closer look at TRAPPIST-1 suggested that some of these terrestrial exoplanets could harbor a lot more water than Earth's oceans. This water could be in atmospheric water vapors, liquid water, and ice for those farthest away. This research determined the density of each planet more precisely, and this research also made TRAPPIST-1 the most thoroughly known planetary system apart from our own. Most notable terrestrial exoplanets include TRAPPIST-1b, TRAPPIST-1d, and TRAPPIST-1e. Why do we search for planets outside our solar system? To find another planet like Earth, right? But what's the criterion, and how do we find such planets? Well, the primary condition for being able to sustain liquid water is the planet's relative position to its star. The region around a star where liquid can exist on the surface of a planet is called the habitable zone. It's an area not so close to the star that makes water evaporate, not so far that it freezes. Another term for the habitable zone is the Goldilocks zone, which means not too hot or cold. We can tell if a planet is in the habitable zone based on the planet's distance from its host star and the temperature of that star. A bigger, hotter star's habitable zone is farther than a smaller, cooler star. There could be as many as 40 billion planets in the habitable zone of stars right here in our Milky Way. So far, we have found about 20. That may not seem like many, but consider this: we may have already found a planet that hosts life, we just don't know it yet. Exoplanets give us hope that we may not be all alone in this universe. But can life exist in such extreme conditions on exoplanets? What exactly is the definition of life with regards to planets outside our solar system? We don't know it yet, but if we can find planets located 2,800 light-years away, we may one day know the answer. If you loved what you just watched, make sure to smash the like button and subscribe to this channel.